Okay, so yesterday we learned how to use the law of cosines to find a side, and it was a specific side. It was a side that was opposite the included angle. So let's just write the law of cosines and try to manipulate and see what else can we use this for. The law of cosines, which again is given to you, is a squared equals b squared plus c squared minus 2bc times the cosine of a. What I'm going to do here, I'm going to solve for the cosine of a. I'm going to solve for it. So I'm going to get everything else to the other side, and I'm going to get cosine of a alone on one side of the equal sign. Okay, so first we're going to subtract b squared and c squared. So we're going to have a squared minus b squared minus c squared equals negative 2bc times cosine of a. Now I'm going to divide by negative 2bc, give me a squared minus b squared minus c squared all over negative 2bc equals cosine of a. Last thing I'm going to do, I'm going to change the signs of everything, which means we're going to have a negative a squared, a positive b squared, a positive c squared, to get rid of that negative, just to make the formula look a little nicer. So we're going to have b squared plus c squared minus a squared all over 2bc equals the cosine of a. Again, all I did was divide by a negative there. So let's draw ourselves a picture and say, what is this giving us? So same thing as before. Over here, when we were using this format, we were looking for a squared because it was alone on one side of the equal sign. In this case, we're looking for angle A. Because it's alone on one side of the equal sign. So if we were to draw ourselves a little picture, we can identify when we could use this formula. So here is a picture of a triangle. Let's label A, B, C as angles. They're capital, so they're angles. Angle A, side A. Angle B, side B. Angle C, side C. So let's circle what we have. That means we have all of this. We have B, we have C, we have A. We have B, we have C, and we have A. And we're looking for that. So now at least we can visualize when we can use this formula. We can use this formula when we have all three sides. More specifically than just having all three sides, let's take a look at which angle we'd be looking for. The angle that we're looking for, take a look at A. That's opposite angle A, right? So A is negative and not in the denominator. So that's a useful way to remember how the alternate law of cosines works. Whatever angle you're looking for, the opposite side is negative and not in the denominator. Okay? So we do not have an included angle. An included angle would mean we know angle A, we know side C, and we know side B. And we're looking for side A. In this case, we have all three sides, but we're looking for an angle. So let's go through an example here. Let's say that we have a triangle. Of 10, 11, and 22. So we know this is a possible triangle because it satisfies the third side rule. The sum of two sides, well, this doesn't satisfy, sorry. The sum of two sides, 21, is greater than the third side. So that we know this is a possible triangle. So now let's say we're looking for this angle. Now, the alternate law of cosines is not given to you. So this is something you should be familiar with. You could always derive it back from the original formula. Cosine A equals b squared plus c squared minus a squared all over 2bc. So the angle that you're looking for, the opposite side is what's negative. So this is 20 and not in the denominator. So we're going to have the cosine of x equals 10 squared plus 11 squared minus 20 squared all over 2 times 10 times 11. So let's clean up numerator and denominator separately as opposed to the previous formula where we plugged it all in one. We're going to do this all separately. So we're going to end up with the cosine of x equals 10 squared plus 11 squared minus 20 squared. Got 111 squared, not 11. Delete. Enter. So our numerator is negative 179. So now you may be saying to yourself, wait a minute, we have a negative here. How is that possible? Well, if we take a look at all students take class, this means cosine's a negative number. All that means is we're looking for a second quadrant angle. So figure not drawing a scale. All right, let's figure out the denominator. 2 times 10 is 20. 20 times 11 is 220. So now we're just going to take the inverse cosine of that. So x equals cosine inverse of negative 179 over 220, which is second cosine, answer, divided by 220. Enter. And we get 144.5 to the nearest tenth. Okay, so this angle here, 144.5. And now what's nice is that we can solve the rest of this triangle, because now if we want to solve for this side, let's call this angle y here. If we wanted to solve for this side, or angle rather, now we would just have to manipulate the formula. I'm going to erase all this work, not that this is gone, just run out of a little space here. I like to put it over here. What I could say is that now the cosine of that angle y is equal to, and I should really capitalize that, the cosine of capital Y is equal to 20 squared plus 11 squared minus 10 squared all over 2 times 20 times 11. And now I can solve for that angle. Just notice, whatever angle you're looking for, the opposite side is negative, 10, and not in the denominator.